This story begins in the year 2006, when some of the world's leading scientists detected a toxic gas in our atmosphere, methane. It was noticed that the amount of methane in the atmosphere had suddenly increased dramatically and was continuing to rise. Methane is a naturally occurring gas that, when released into the atmosphere, warms the Earth. Think of it like a blanket we use to keep ourselves warm during winter. In the same way, methane acts like a blanket around the planet. The heat remains trapped inside, causing the Earth to become even warmer.
In fact, methane is far more effective at warming the planet than ordinary carbon dioxide. When methane levels suddenly started rising in 2006, scientists initially believed that the increase was probably caused by human-generated pollution. But when they investigated further, what they discovered left everyone shocked. It was a massive mystery that had been hidden deep within our planet. How was this methane gas being produced, and why was its concentration continuing to rise?
How does the scientific community detect methane gas? And most importantly, is this methane increase a sign of the end of the world, or does it indicate a major climate shift ahead? Welcome back to another video.
Scientists already knew that spikes in atmospheric methane generally occur about once every 100,000 years. They learned this through information gathered from ice cores drilled out of frozen regions such as Antarctica and Greenland. Imagine that every year, about 1 meter of snow falls in Antarctica. That snow traps tiny amounts of atmospheric air inside it. The following year, a new layer of snow covers the previous one. Over thousands and even millions of years, these layers continue stacking on top of each other.
When scientists drill deep into the ice and extract an ice core, it acts like a time machine, preserving a record of Earth's ancient atmosphere. By analyzing these ice cores, researchers can determine which gases existed in the atmosphere during different time periods and in what concentrations. Using this method, scientists discovered that throughout Earth's history, there is usually a point roughly every 100,000 years when methane levels rise dramatically. This is typically a sign that an ice age is coming to an end and that the Earth is about to start warming again.
As an ice age ends, enormous amounts of ice melt over a relatively short period of time. Within just a few thousand years, the planet begins to resemble the climate conditions we experience today. But here's the problem. Methane levels like these were last recorded around 12,000 years ago, when the most recent ice age was ending. So why is methane rising again so soon? Is our planet moving toward another major transformation? Or are we facing a completely new threat?
To understand this mystery, we first need to look at Earth's history. Right now, we are living in a period known as the Quaternary period. This period began approximately 2.5 million years ago and continues to this day. The Quaternary period is divided into two major parts. The first part is called the Pleistocene epoch. It began about 2.5 million years ago and lasted until roughly 12,000 years ago. During this era, Earth experienced repeated ice ages.
Huge portions of the planet became covered in ice. Then, after thousands of years, much of that ice would melt away. Later, the ice would return again. This cycle continued over and over. It was during this period that humans evolved and spread across the planet. It was also during this time that massive animals, such as mammoths, went extinct. Then came the second part of the Quaternary period, the Holocene epoch. This epoch began around 12,000 years ago and continues today. During the Holocene, ice coverage decreased significantly, and Earth's climate became much warmer and more stable. Because of this stability, humans learned how to practice agriculture. As glaciers melted, fresh water resources became available. People began building villages and settlements near these water sources. However, there is one important point that often causes confusion.
Even though we are living in the warm Holocene epoch, technically speaking, we are still in an ice age. The reason is simple. Large ice sheets still exist at Earth's poles. They're just not as massive as they were during the peak of the ice ages. Only when there is no permanent ice left at the poles can we truly say that the ice age has completely ended. But this raises another question. What exactly causes Earth to warm up and eventually end an ice age?
Scientists have identified 3 major factors responsible for these long-term climate shifts. Together, they are known as the Milankovitch cycles. The first factor is called eccentricity. Earth revolves around the Sun in an orbit. Most of the time, that orbit is nearly circular. However, over long periods of time, the orbit can become slightly more oval-shaped. When Earth's orbit becomes more elliptical, there are points during its journey around the Sun or the amount of solar energy received can change. This eccentricity cycle takes approximately 100,000 years. Over that period, Earth's orbit gradually shifts from being more circular to more elliptical, and then back again. However, scientists believe that eccentricity alone is not responsible for ending ice ages. Another major factor is Earth's axial tilt.
As Earth travels around the Sun, it is tilted at an angle of approximately 23.5 degrees. But this tilt is not constant. It slowly changes over time. When Earth is tilted more steeply, the polar regions receive more sunlight during summer. As a result, ice at the poles melts more rapidly. Scientists estimate that this tilt cycle operates over roughly 41,000 years. During that time, Earth's tilt varies between approximately 22.1 degrees and 24.5 degrees.
The third factor is called precession. Earth's rotational axis does not remain perfectly stable. Instead, it slowly wobbles, much like a spinning top. This wobbling changes the timing and distribution of the seasons. The precession cycle lasts between approximately 19,000 and 23,000 years. Together, eccentricity, axial tilt, and precession create long-term warming and cooling cycles on Earth. Ice plays a very important role in this process.
Because ice is bright and white, it reflects a large portion of the sun's energy back into space. But when that ice melts, the darker surfaces underneath become exposed. These surfaces include soil, rocks, and ocean water. Unlike ice, dark surfaces absorb much more solar energy. Most people already know that darker colors absorb heat more effectively. As more heat is absorbed, temperatures rise. As temperatures rise, even more ice melts. This creates a self-reinforcing cycle. But Earth's warming accelerates even further when greenhouse gases trapped within the planet begin to escape. These gases include carbon dioxide and methane. They are often stored in the oceans or locked inside frozen ground known as permafrost. As temperatures rise, these gases are released into the atmosphere. Once released, they trap even more heat, causing additional warming. So the big question remains, if everything was following its natural course, why did scientists observe such a dramatic increase in methane beginning in 2006? After all, the event that ended the last ice age happened around 12,000 years ago, not 100,000 years ago as these natural cycles would normally suggest. During the 20th century, the natural gas industry expanded rapidly. As a result, human-caused methane emissions also increased significantly. However, by the 1990s, methane growth rates appeared to level off. So where did the new spike that began in 2006 come from? Methane is a unique gas because it is produced not only by human activities, but also through natural processes. As mentioned earlier, large amounts of methane are hidden beneath Earth's surface. These gases are trapped in wetlands, oceans, and frozen permafrost. Melting ice can act as a trigger that releases them. Thanks to modern technology, scientists can now identify where methane emissions are coming from. One method involves satellites that send laser beams with very specific wavelengths toward Earth's surface. These wavelengths are designed so that methane gas can absorb them. When the reflected light fails to return to the satellite, it indicates that methane absorbed the beam at that location. Using this technique, scientists have created detailed global maps showing methane emissions around the world. Using this technology, NASA teams mapped a massive methane plume above a large landfill site in Iran. The methane cloud stretched for approximately 3 miles. Every year, it releases around 73,440 tons of methane into the atmosphere. To put that into perspective, that's roughly equivalent to the combined weight of about 180 Boeing jumbo jets. If calculated on an hourly basis, that amounts to nearly 8,500 kilograms of methane being released every single hour. But even larger methane emissions have been detected in Turkmenistan. There, scientists identified 12 major emission points associated with oil and gas extraction facilities. At these locations, enormous quantities of methane are escaping into the atmosphere every hour. However, scientists believe that these industrial sources do not fully explain the methane spike observed since 2006. In fact, they may not even account for half of it. A much larger portion appears to be coming from forests and natural ecosystems, especially from regions that sit on top of permafrost. Permafrost is permanently frozen ground that has remained frozen for thousands of years. But as global temperatures rise, this frozen ground begins to thaw. When permafrost melts, ancient organic material that has been locked underground for thousands of years starts to decompose. As microbes break down this material, large amounts of methane are released. Scientists believe that this process is one of the major reasons behind the recent methane increase. The biggest challenge with methane is that once it enters the atmosphere, it becomes extremely difficult to capture. In landfills and industrial gas fields, methane can often be collected before it escapes. But methane released across vast forest regions cannot realistically be captured. In fact, many modern landfills are already equipped with systems that collect methane and use it to generate energy. The byproduct of this process is carbon dioxide. While carbon dioxide is still a greenhouse gas and contributes to climate change, it is generally considered less potent than methane over shorter timescales. Methane remains in the atmosphere for roughly 10 years. After that, chemical reactions gradually break it down into carbon dioxide and water vapor. But that doesn't mean the problem simply disappears. During the years methane remains in the atmosphere, it traps a tremendous amount of heat. And that extra warming can trigger additional environmental changes. More warming leads to more ice melt. More ice melt exposes more dark surfaces. More warming also causes more permafrost to thaw. And more thawing releases even more methane. This creates what scientists call a positive feedback loop, a process that can continue reinforcing itself. This is one of the reasons why scientists are paying such close attention to methane levels today. The concern is not just the methane already in the atmosphere, The concern is how much more methane could still be trapped underground, waiting to be released as temperatures continue rising. And that brings us back to the mystery that started in 2006. Why are methane levels rising at a time when the planet is already relatively warm?
Why are we seeing methane concentrations comparable to those associated with major climate transitions in Earth's past? These questions remain some of the most important topics in climate science today.
The most concerning aspect is that although Earth has experienced elevated methane levels before, such as those recorded around 12,000 years ago, those increases occurred during the ending stages of an ice age. Today, however, the situation appears different. Most of the major glaciers have already melted significantly compared to their ice age conditions. Yet methane levels are once again rising rapidly. Scientists have never observed a situation quite like this before. And that may suggest that Earth is entering a new phase. But the truth is that predicting exactly what comes next is extremely difficult. No one can say with complete certainty whether the current methane increase means that the ice age will finally come to a complete end. Nor can anyone confidently predict whether Earth might eventually move toward another ice age in the distant future. The challenge is that scientists have very few historical reference points for comparison. There is no clear example in Earth's known climate history where methane levels rose this dramatically, again, only 12,000 years after the previous major warming event. Because of that, researchers are working with limited historical data. We still do not know how high methane concentrations might eventually climb. We also do not know exactly how Earth's climate system will respond if these emissions continue increasing. And if a significant portion of this methane is being released naturally rather than through human activity, controlling it could be extraordinarily difficult, perhaps even impossible.
That is what makes this issue so important. Methane is not just another greenhouse gas. It may be one of the most critical clues to understanding where Earth's climate is headed in the future. Whether it signals a major climate shift, an acceleration of existing warming trends, or something entirely unexpected, scientists continue to monitor it very closely. For now, many questions remain unanswered. What we do know is that methane levels are rising.
We know that methane is a powerful greenhouse gas, and we know that Earth's climate system is incredibly complex. The coming decades may reveal whether this methane surge is simply another chapter in Earth's natural climate cycles, or the beginning of something we have never witnessed before. We hope you enjoyed this video. Don't forget to like and share it with others. Thank you so much for your continued support and for all your encouraging comments. We'll see you again in the next amazing video.